Good morning, Eva. How are you? How are things in Serbia?
Oh, hello, Helena. Nice to see you, at least via video link. Well, the usual here. I'm at the university working with my students. And how's life in Lisbon?
Actually, today is a rainy day and I'm also at the university with my students. And I have a question for you. I just got these crowns from the lab. They are monolithic zirconia crowns. And I was wondering, what type of interfaces are you using for these crowns?
Well, you know, there are so many different abutment types, restoration materials, and their combinations nowadays. We actually, for the most of the posterior single unit cases, use these monolithic zirconia crowns with standardized titanium abutments.
Actually, we are using those too, but my question is, this cementation interface, do you think it's biomechanically stable?
Good question. Actually, I have the same question too. You know what? There's a great new article in the latest issue of International Journal of Prosthodontics. So it can help us answer this question. It deals with biomechanical properties of actually these kinds of implant restorations. And that's exactly why Alexis Ioannidis from Zurich is joining us today.
Perfect. Let's call him. Yeah.
Good morning, Alexis. Great to see you. Hi. Could you please summarize for us this interesting article?
Hi, Helena. Hi, Eva. It's a great pleasure to see you, and I'm very happy to have this interview with you on our study. And I think it's the best to share some slides with you to show the outcomes of our study. Here in Zurich, we very often use these CAD/CAM crowns, which are cemented on titanium abutments. And here you can see some very nice SEM pictures, seeing on the left side the CAD/CAM crown, then the titanium abutments. The entire complex is then screwed on top of an implant. But there is a third part, and probably also the weak part of this entire complex, and this is the cementation interface between the CAD/CAM crown and the titanium abutment. What we did in our study, we did produce with different workflows, a chair side and a lab side workflow, different restorations. They had all the same outline, made out of lithium disilicate or made from a PICN material, and they were cemented on standardized titanium abutments. And then the specimens were then mounted in a customized holder to be able to exactly have a very close look at this interface. Again, you can see on the bottom, you can see the crown, and then you can see the small line between the white arrows. This is the cementation interface. And here we did a very zoom into this area. And then we did measurements before and after in vitro thermomechanical aging, and we investigated the gaps which were formed or not formed during this procedure.
So what were the results of your study?
Interestingly, when we have a look at the results, we can see here the different groups. We don't have to go too much into the details. We have different restorative materials, different interfaces. Some of them were prefabricated, indicated with a P, and some were manufactured during the milling procedures, indicated here with an M. But irrespective of the details, it was very interesting that we have found very often gaps between the restoration and the titanium interface even before the aging procedures. And we were surprised because these were all fabricated and cemented by a very experienced dental technician, and they were meticulously controlled under high magnification. But even though we had around 50%, which showed some gaps even before aging. And then when we looked at them again, exactly at the same areas, there was an increase in the gap formation about of 30%. This was very interesting.
Oh, that's really interesting. And Alexis, are there some specific clinical implications that you could suggest to our readers?
This is difficult to say. I think it would be very interesting to study to study something similar in a clinical setup and to see if these gaps have any impact on the peri-implant health. But yet it's not clear, because probably they are around 100,000 of patients run around with these interfacial gaps. We very rarely can see some decementations, and maybe they are not that of that much importance, but we don't know yet.
So, if you would like to have more information regarding this amazing research done by the Zurich group, please go to the International Journal of Prosthodontics and read it. Please help us bring the journal to life.